I'm Chimela Ariasaf, and this is my presentation about the week 3 course from the Coursera about machine learning operations, the data operations, and development operations. We start with the key components of GitHub ecosystem, and these components include the repositories for version control. We have the issue tracking, the project management tools like the GitHub project. We have the collaborative coding through pull requests and a push requests, then even the merge requests. Then we have the GitHub actions for continuous integration and continuous deployment. Then we have the GitHub packages for managing software packages. Moving to the next slide. On the next slide, we talk about the cloud developer workspace advantages, and this includes it provides developers with flexibility to work from anywhere. Then we have the collaboration capabilities, like developers can collaborate to push their work there. Then we have scalability, many people can access our resources from the cloud. Then we have access to a wide range of development tools and integration with other cloud services. And then we talk of the demo of GitHub Copilot. And this is just an AI powered code completion tool, and it suggests code snippets and helps developers to write code faster. Just that. And it can also help developers to understand the context to generate relevant code suggestions. On the next slide, we talk about the pipelines for data ops using the step function. Data ops pipelines using Amazon Web Service same function. They just allow the orchestrating and automating complex data workflows. And this include the data ingestion, the processing, the transformation, and analytics tasks with the built-in error handling and the retry mechanism. Then we talk of the query Databricks pipelines, and these Databricks pipelines enable users to create schedules and monitor workflows for data engineering and data science cases using the Apache Spark. On the next slide, we talk of the data ingestion and processing pipelines on the Amazon Web Service, and this offers various services like the Amazon Web Service Glue for data ingestion, the Amazon Web Service Lambda for serverless processing, the Amazon S3 for storage, then the Amazon Redshift or the Amazon Athena for analytics to build end-to-end data pipelines. Then we talk of the Marco Polo step function. The Marco Polo step function just refers to the Amazon Web Service function workflow and coordinates the execution of tasks across distributed systems, all the services, and it is used for orchestrating complex workflows in the Amazon Web Service. In the Amazon. To the next slide, we talk of the serverless data engineering pipelines on AWS. Serverless engineering data pipelines leverage services like Amazon Lambda, the AWS Glue, the Amazon S3, and the Amazon Dynamo database to build scalable, cost-efficient, and flexible data processing workflows without managing server infrastructure. You don't have to focus on the server, the infrastructure of the server to use those. We talk of transforming data in transit on the Amazon Web Service. And the Amazon Web Service provides services like the Amazon Glue, the Amazon Data Pipeline, and the AWS Lambda. And these allow transforming data in transit as it moves between different destinations. Then we move to the next. We talk of the Python function. We talk of building Python function from zero. From zero meaning from scratch. We start from scratch, and this involves building functions that involve defining the function's logic, writing the code, and testing it, like to ensure it performs the required tasks efficiently. We talk of building NLP projects with Python Fire. Python Fire is just a library, and this library automatically generates command line interfaces from Python objects. And building an NLP project with Python Fire just involves using it to create a user-friendly command line interface for, for interacting with the NLP models. Moving to the next slide, we talk of using Google Cloud functions, and these functions are just serverless compute services that allow developers to deploy and run event-driven functions in Google Cloud Platform. Yeah, and helps developers to build microservices, APIs, and automation tasks without managing servers. Then we talk of deploying a Rust Azure function with GitHub Actions. From the previous slides, we saw GitHub Actions like GitHub projects, collaboration, the pull, the push, the merging, version controls, automatic deployment, all that. And these actions can be used to automate deployment of Azure functions that are written in Rust by defining workflows that build, test, and deploy the functions. Moving to the next slide, we talk about operation pipelines, DevOps, DataOps, and MLOps. And the operation pipelines in this just refer to the automated workflows for deploying, monitoring, and managing software data and the machine learning models in production environments. Just that respectively. Then we talk of the greedy optimization. And grid optimization is a problem solving strategy. It's just a problem solving strategy where we use algorithm to make the local optimal choice at each step with the hope of finding a global optimal solution. We just use this to just finding an optimum solution to the problem. But in return it may not produce the most optimal solution. There may also be other solutions we can go with.